Hey everybody, here's another little video here for solving systems of equations. Little reminder, this is how to solve through elimination. So in the first example, I'm going to provide a system. Should look familiar if you viewed either the substitution or the graphing videos. It's the same system, just we're going to solve it with elimination. So using elimination, I'm going to give the first equation in our standard form, and the second equation is also going to be given in standard form. When you eliminate, you have to pick a variable to eliminate. So, and I'm going to do this one of two ways. I'm actually going to do it one way, and I'm going to show you how to do it the other way. So the first time, the variable that I'm going to eliminate is going to be x, and then I'm going to do the problem again, just to show you that you can solve for y. So when we eliminate, remember we went through the process by adding equations. So when we add variables, we want to make sure in order to eliminate them, they have to be opposite signs. So if we ever have to multiply one or both equations, we want to make sure that the variables are opposite signs for the particular variable we're trying to eliminate. So there is no solving for like y or anything like that, but did you want to make sure that all your variables are lined up? Notice how in this problem the x's are in a column, the y's are in a column, and everything's lined up. The equal sign is in the same spot, so you want to make sure that that happens before you start doing anything, and that is the case in this particular problem. So in the first way, I picked x in order to eliminate. So in order to do that, I see, oh, well, if I multiply the bottom equation by a -2, then when I add 2x and a -2x, they should be eliminated. Now remember, you distribute that -2 to every single thing. So notice it became -2x, +4x, and a -12. Then you just do column math, right? 3y and 4y become 7y, and -9 and a -12 become -21. You'll solve for one variable here, and then when you get that, you have to plug it into either equation. Remember, you can plug it into either equation because this is the point of intersection between the 2 points, so it should work for both. So I plugged it into the top equation this time, and I got, surprise, surprise, x equals 0. And I did make a mistake in copying here. Originally when I did it, I copied 6 for some reason. I went through and changed it back so that it looks like the way it should. We should get x is 0. Don't forget to write your final answer as an ordered pair because it is a point of intersection. So our answer is 0, -3. Now for the second way to solve it. So the first way I picked x. The second time, you don't have to do it both ways. You just pick one variable and you go with it. So maybe you decided, hey, I'm going to eliminate y this time. So it's the same equations. I'm just copying the original down here. So nothing changing here. The directions would read solve the system or solve this system by elimination. So when I choose to eliminate y, you should notice that, wow, they're really different. You can actually take those two numbers and multiply them together. That's why I originally wrote 3 times 2 equals 6. So when you look at y, I can multiply it by 2 on the top one and by 3 on the bottom one, and make sure you distribute those to each one. So right now I'm writing the bottom equation and I'm distributing the 3 to every single thing there. When I add the two equations, the y's are eliminated, and then I get x equals 0. I'm going to plug that back in, woohoo! And then we will use the bottom equation this time just to show you that you can use either equation when you're plugging it back in, and you should end up getting the same solution of 0, -3. So here we get y equals -3, and then don't forget to write your answer as an ordered pair, 0, -3. That's all for now. See ya.